Alright, so let's talk about the remove duplicate from sorted list 2. So you're given the head of the single linked list and you have to remove the duplicate number in the list and you have to return the linked list in sorted order. So in this question you can use the DFS and BFS. For DFS you're using recursion, and then for BFS you're using iteration. And then for the recursion solution, this is pretty simple. Like you basically need to check your current value and also the next value, right? So if my head is right over here, right, and I have to check does my head val is equal to head next val, right? So head next val. So if they are not equal, then I can move my head from 1 to 2, right? So I will move my head to here, right? And then basically like I always keep the track of the pointer, right? So when I'm using a recursion solution and then later on you will backtrack, right? So I will still keep my head, and the only thing is the pointer changing. So this is how you actually solve it. So let's start the recursion solution. So this should be simple. So I do have a base case. I'm going to leave the base case right over here. But how do you actually check the value? It's going to be head.val does not equal to head.next.val, right? If they are not equal, then you can just change the pointer head.next to delete duplicate head.next. So basically you just have to keep updating your head.next, right? And then you have to return head. So when you recursion calling back the function, then you'll return the first one, which is the beginning of the linked list. So what if they are equal? So just for example, so right over here, your head is right over here, right? And you want to delete this too, right? So basically you need to connect your pointer to here, right? And then if they are equal, then you delete this, and then you just keep swapping, right? So this is pretty much it, right? So you just have to avoid the duplicate. So we have to make sure our next head.next. So our current head is over here, right? We have to make sure head.next is not null first, right? It's not null. Then we check the value. If they are the same, then we just move our head pointer to the next one, right? Then starting. So while head.next is not null, and also head.val equal to head.next.val, then you move your head to the next one, right? Then afterward, then which means they are not equal, right? So when they are not equal, I will probably say right over here. So this is the head, and the head.next.val is actually 4. 3 does not equal to 4, right? So I will have to make sure the next one is also not duplicated in the linked list, right? So you still have to call a function. So call the recursive function, and then return delete duplicate head.next, right? Our current head is right over here, right? So head.next is 4, right? So you're still going to check for the rest of the node in the linked list. So I still haven't run my base case. So what happens if the head equal to null, right? So at the end, probably at the end, head will be equal to null, right? Because I keep calling the head.next, right? So what if head is actually equal to null? Or head.next is equal to null, right? We have two such scenarios, right? What if we have an empty list, right? If you have an empty list, then head equal to null. And if you keep calling head.next, right? Somehow your head.next equal to null, right? Because you will keep checking head.next.val, right? And head.next.val, right? So in this case, you just return null, right? And this is just return head. So alright, so let me run it, and then here we go. So let me submit. So this is the recursion solution. So the time and space is pretty simple. The space is going to be constant. The time is going to be all of n. Traverse every single node in the linked list, and then this is the time. Space is all of 1 constant. Alright, so let's talk about the iterations. So iteration is a little bit straightforward. So you have have to create what? You have to create a dummy node. So dummy node right over here, and then you point at the next, right? And then you also have to create a previous node which equal to what? The dummy first, right? And then at the end, so while you're traversing based on your head, so you're traversing the linked list based on head, right? So basically you just have to check, does my previous is dot next is actually equal to no. It's actually equal to head, sorry. It's actually equal to head. If this is true, then you just have to previous equal to previous dot next. So what does this mean? This is pretty simple. So let me change another color. So 1 does not equal to 2, right? So if they are not equal, right, then you need to keep both of the nodes in the for the output linked list, right? So you have to know, like this is by default dummy.next equal to head, previous equal to dummy node, right? So if the previous dot next equal to head, right, which means you are not moving, since they are not equal, so you are not moving your head, right? So you will move your previous to the head. So this is the first step, right? Then you move your head every single time by 1 when they are not equal, right? So again, once you check your neighbor, so head.next, head.val does not equal to head.next.val, right? So you have to keep this, right? So then we check, does the previous next equal to head? Yes, this is true. Then we move our previous equal to head. Now the funny thing is right over here. Then you move your head, right? And you have to know, does my head.val equal to head.next.val? True, right? Then you move your head. Does my head.val equal to head.next.val? No, right? So you stay here. Then you have to know, like, does my previous dot next equal to head? No, right? Then you have to say previous dot next equal to head dot next. So this means these are duplicate, right? And then I move my pointer previous dot next to here. So again, I have to check my head. So head will move on. So I will have to say, okay, does my head dot val equal to head dot next dot val? This is true, right? Then you move your head. And does my head dot val equal to head dot next dot val? They are not, right? Then you're still moving your previous pointer to head dot next. Alright, so this is pretty much a solution. So list node dummy head equal to new list node. By default this is 0, and then the next point is going to be head, and my previous equal to dummy head. So while the head is not null, I'm going to keep traversing, and the head will always move my pointer by 1, and I will return dummy head next. This is everything by default, right? So while head next is actually equal to null, and also head val equal to head next val. Then you move your pointer head equal to head next, right? So the reason why we're using head next equal to null first in the while loop, right? This is because you have to make sure the comparison is valid before before you execute this one. Head next val equal to head val, because this will return null at some point, right? So you cannot compare this. Right. So if the previous dot next is actually equal to the head, which means this is pretty much the beginning. Dummy dot next equal to head. So previous definitely equal to previous dot next equal to head, right? So you have to make sure your previous equal to previous dot next. Just keep moving your pointer. So else, basically you just traverse rest of the linked list, which means they are duplicate node just between the previous and head. So this is pretty much a solution. So let me run it. I have a typo, dummy previous equal to dummy head, and head dot next equal to okay, header next does not equal to null, right? Sorry about this. You have to make sure it's not equal to null, and then so you can compare. And this is pretty much it, right? So okay, yes. Sorry for the mistake. So this is the iteration solution. So the time and space. This is going to be a space constant time, all of them, right? Checking every single listener in the linked list. And this is pretty much a solution. And once again, I made a typo right over here. So you have to make sure the header value is equal to header next value. But before that, you have to make sure header next is not equal to null. So you won't check the null with the header value, right? So this is pretty much the idea. And yeah, here we go. So I will see you later.